everyone, this is a summary for Chapter 5, Applied Behavior Analysis, a white book. Chapter 5 speaks about improving and assessing the quality of behavior measurements. And basically, to be most useful for science, measurement must be valid, accurate, and reliable. Valid means measure directly a socially significant target behavior, measure a dimension of the target behavior relevant to the question, and ensuring that the data are representation of the behavior under conditions and during times most relevant to the reason of measuring it. Accurate means that it reflects or matches the true state of the behavior. Reliable means the same values across repeated measures, so if you measure the same thing over and over again, you really should be receiving or getting same data or similar measurements across time or across repeated measures of the same behavior. The threats that we face to validity is indirect measurements. So when we do questionnaires or interviews, sometimes we don't get valid data or measurements because we're not directly observing the behavior, and we may get answers that are not objective or basically do not reflect the true state of the behavior. Measuring the irrelevant dimension of behavior. Sometimes we may choose a wrong dimension to measure. So for example, we'll use frequency rather than duration, and this could be an irrelevant dimension to the behavior or to the question we're trying to answer. So for example, if we are trying to study measurement for a behavior such as running or flapping of the hands, we most likely will use duration to see how long does the behavior last. But if we use frequency, we won't be able to have accurate and valid measures. So, and that's because we chose an irrelevant dimension to measure. Measuring artifacts, so data that give a misleading picture of the behavior because of the way measurement was conducted. So the way we collect data or the way we measure behaviors could be the reason why we have invalid data, such as poorly scheduled observations. If you know that the behavior happens throughout the day, and you schedule your observations only in the mornings, you may collect invalid data because, again, it does not reflect the true state of the behavior. Discontinuous measurements. Discontinuous measurements can be partial interval recording, whole interval recording, and momentary time sampling. We have to be very careful when we choose one of these to measure behaviors, and we have to make sure we're using the appropriate one. Otherwise, we will be having invalid data because of the way we collected or looked at the behavior. Insensitive or limiting measurement scales. So this also could be like rating scales. For example, asking the parents to rate the behavior occurrence from 1 to 5. And this is a very vague way of taking data because again, it doesn't really specifically tell the parent what does the 1 mean, or the 2, or the 3, or the 4, or the 5. It's a very vague scale. So this also may we may end up having invalid data or data that doesn't really help us in our program or our study. So the threats to measurement of accuracy and reliability, mainly human observers. So we as humans, we make mistakes while taking data, and these could be really impact our measurements and impact the accuracy and the reliability of our data. So for example, poorly designed measure system. So the way you're going to collect the data could impact the reliability and accuracy. So if you are using a very poorly designed scale or measure, such as interviews or basically just very vague way of collecting data, you may end up with a very poor reliability and accuracy. And when you do it repeatedly, you may end up with very different data, and it would not be reliable this way. So you really have to choose and design the measure system you're using very carefully. Inadequate observer training. If you do not have a person who is able to take accurate measurements because of the lack of training, that might be a problem. You really need to make sure the observer is trained and understands the measurements, understand the scales, understands what exactly he's looking at. So observer training is very important. Observer drift. Basically, observer drift can happen with anybody. So if you're looking at a behavior, specific behavior, what can happen is after, like, say, a week or two of collecting data, you may start drifting by looking into a different behavior. So if you're looking at a specific behavior, such as hitting your peer, and this falls under aggression, you may end up looking at hitting a teacher instead after a couple of weeks. So you might drift. Your focus may drift. So the solution to this is usually a team inter-observer agreement has to be done, and people have to basically work on the same. Like, a team has to be working on the same measurements or on the same behavior, reviewing the data and looking at it and doing it repeatedly. Observer expectation. So if you're going in a study or into you're going to collect data with results in mind or an expectation in mind, this also may impact on the way you're collecting data. It might make you focus more on specific measurements or behaviors that kind of fit your expectation, and so you end up having kind of trying to show that your hypothesis was correct. So expectation also happen, and that's why you need team. You need to do an IOA. We're going to speak about IOA in a second. Observer reactivity, which basically means that you know that someone will review your data or your measurements afterwards, and that may impact your way of collecting the data. Assessing accuracy and reliability of behavior measurement. So how do we try to minimize any threats? Assessing accuracy continuously. Assess if observers are reliably applying a valid and accurate measurement system. Remeasure the same behavior events, and use inter-observer agreement. So what is inter-observer agreement? It's two or more observers reporting the same observed values after measuring the same events. So basically, if two or more can go in the same environment, look at the same event or behavior, and take measurements and then compare their data. IOA is used to determine competence of new observers, assess observer drift, assess if target behavior definition is clear, convince others of believability of data. Also, IOA is the same measurement, same participants, same events, and independent of the influence of others observers. So of course, when you're observing, you won't be in contact with the others. You won't really talk with them or compare results compare data while you're taking them. You do it afterwards. Also, some studies would send someone in the environment to take data while they're videotaping what's happening, and then someone else will look at the videotape later on and take data based on what was recorded, and then they compare the person who was inside the environment with the person who reviewed the data on tape, and then they try to get an inter-observer agreement percentage. This way you won't be in contact with each other in the same environment, so that they won't influence each other. IOA is a percentage of measurement agreement that's the most used method in applied behavior analysis. So there's methods for calculating IOA. Event recording IOA is one of the examples is total count. So basically, you're counting all the times, that you're saying that the behavior either happened or didn't happen, and you're comparing it with the other person. And the way you calculate it is you put the smaller count divided by the larger count, multiply by 100. The mean count per interval is basically you're taking each interval and you're calculating the mean. It's not like total, where you take every, the total of the behavior numbers and you compare it. You're taking here's a mean, the average. This can be a little bit misleading because, for example, if you say that there were a total of 15 responses and both the two people who observed agreed that there were 15 responses in 30 minutes, this is 100% agreement here. However, if you look at a mean of each interval, which could be 5-minute interval, it could be 0 to 100, because I could say that in this 5 minutes it happened, but you say it did not happen. Even though we both have total of 15 in the 30 minutes, for each interval we do not have 100% agreement. So that might lead us to have 65.3% mean count per interval, IOA, which is a very low percentage. So the mean count per interval, IOA, can be sometimes misleading. So you have to be very careful when to use it and how to use it and how to calculate it. Exact count per interval, IOA, is the most stringent, and it basically looks at the exact count per interval, not the total of the whole session. It's per interval. Trial by trial IOA is basically the agreement between two observers who measured the occurrence or the non-occurrence of a discrete trial behavior. So we're basically saying it happened or it did not happen by each trial, if it happened or not. So this could be used in DTT and so forth. Total duration, IOA, the mean duration per occurrence, so how long did it last, and then you take the average between two people. So this is very meaningful because it tells you all the time, like the duration of each time it happened, and then the average of the behavior, the time of the behavior, how long does it last, say per day, for example, and then you compare the results of two people, and if you have very similar average and you have a high percentage of IOA, then it would mean that your measurements or data is valid. IOA for data obtained by interval recording and time sampling. So basically, interval by interval recording, IOA, the first observer record for each interval is matched with the second observer record for the same interval. So they compare each interval, like 5 minutes or 5 seconds. They compare each of them and see, the percentage of agreement. Scored interval IOA. They use only those intervals that both or either observers recorded the occurrence of the behavior are used. So even if you say that didn't happen, but the other person said yes, it happened, they will use it or calculate it as yes, it happened. And these are used with behaviors that happens at a very low frequency. It rarely happens, or the frequency is very low. Unscored interval IOA is only those intervals that both or either observers recorded the non-occurrence of the behavior are used. So even if I say it happened and my peer says it does not happen, they will go with it did not happen, because it's called unscored. And this is because, again, these behaviors could happen at a very high rate. So we go with the unscored interval if one of them say it didn't happen, or both of us. However, if both of us says, of course, it happened, then it would not be, it would be taken as it did happen. Okay. The calculation of all the kinds of IOAs are very simple if you understand the reason behind, or the meaning behind each IOA, or what are you trying to basically figure out. They're all in the chapter 5 in the book. And I mean, if you understand what each IOA means or calculates, you'll be able to understand the way to do it very easily. So IOA should be used for every condition in a study, of course. So it's not just for the total study, it's in each condition. So if you're doing baseline, you do IOA, and then if you do a treatment, you do an IOA, another IOA. A minimum of 80% agreement is needed for us to say that it's accurate data and valid. However, it also depends on the nature of the behavior. So sometimes we may require higher percentage of IOA, like 90%, for us to say that the data or the study results were valid. IOA can be reported in narrative or graphic form, and IOA reported in studies in the same way as results. So it's part of the study. It cannot be excluded, and it has to be reported or basically shown in the study in the same section as the results. That was a very brief summary of chapter 5. Thank you so much. And if you are following the chapters, please subscribe to the YouTube channel. I'm going to now continue 5 chapters in Arabic, and I'm going to go back to English. Thank you so much.